Hello friends, in previous video we were discussing about biasing of differential amplifier, and we concluded that this configuration is this first one is correct configuration, and second and third are not correct configuration for biasing differential amplifier. Here I would like to add one final point. For biasing. So if we are considering say NMOS device, and here we are having a tail resistance, some tail resistance. So or yeah, and some load resistance here, now I would like to add final point here is that this is tail node. Okay, say this is VT. So tail node should be, or you can say it's a mandatory condition or must be, you can say biased or set by devices or elements above this tail node. So this tail node is biased by these devices, not by this resistance. Okay, so here we cannot use resistance, we should use current source. So current source is not going to bias this point, tail point, and this source node, say here VICM. So here VT will come like VICM minus VGS. Okay, so it is easy to bias tail node if we are going to bias or set this node by device above this node, and similarly these drain nodes of these devices, these output nodes VO1 VO2 are set by elements which are above these nodes, because say here this is 2 IB current, IB will flow from here, IB will flow from here. So bias for VO1 and VO2 is VDD minus IB RL. So in this way we can easily bias differential amplifier. Now suppose we are taking PMOS diff pair. So PMOS diff pair, then in this case things are opposite. So this is VICM. So this tail node is set by device below this. So this source node is basically setting here and here this tail node, and RL is setting VO1 and VO2 node. That is, say this is 2 IB, this is IB. So VO1 VO2 is IB into RL. So in case of PMOS it is opposite. So basically one conclusion here is that low impedance node is going to set any node voltage. For example, if we are taking it like this, so this source node is a low impedance node, and this is going to set value of this Vx. And suppose we are taking say some diode connection, say this is PMOS and some circuit is here. So this node is low impedance node. This is source node is low impedance node. So this is going to settle this Vx. So low impedance node is going to actually set or bias that node. For now in differential amplifier, this is low impedance node source, so this should set this node, tail node. Here this is source node, this is low impedance node, this should set this node. And now here in this case, this is if we see towards drain side, this is high impedance node, so RL is less than RO. If we are seeing in drain, RO is this is RDS, so RL should set VO or VO1. Similarly here in case of PMOS, this is RO, and RL should set this VO1 or VO2. RO is greater than RL. So you should check which device is providing low impedance node. That device is going to basically set bias voltage on that node. So low impedance device is going to set bias voltage on that net. So this is 1 point, this is 2 point. So these 2 points are important point for biasing purpose. No. So this second point is valid everywhere in all kind of circuits, and if circuit consists of this kind of structure, if circuit consists of this kind of structure, then source node. So here some VB voltage, so Vx is set biased by this source node, or you can say VB minus VGS. So this voltage, this device is going to bias this Vx. Similarly here in this case, this is direct connection, and this device is having low impedance, so this device is going to set this Vx voltage. So this is for all kind of circuits, so you should remember this point for biasing purpose. So yeah, I would like to add these 2 points for biasing purpose. Thank you.